Okay, so welcome to part 2 of our 123D. Right here we have a boost converter. As you can see at the bottom right hand corner, we have this is just a basic boost converter circuit. So what is different about this is that it actually employs a feedback control. So you can see on the top here with the op-amp, we are using the LM741. This actually acts as the error amplifier for our circuit. By tuning this potential meter over here, we can actually adjust the steady state output of the op-amp. And then this op-amp is fed into this 555 timer, which actually you can see from this circuit that it's a 50% duty ratio. However, by changing the input voltage, due to the non-linear characteristics of the 555 timer, we can actually slightly change the duty cycle about its fixed point. And since this is a 12 to 24 volt converter, boost converter, we will need it to be around 50%. So with these minute adjustments, we definitely can get it to run at the range we want it to run. So this is the strip board version of the boost converter. As you can see, there's an inductor here, and this is a heatsink which is attached to the MOSFET at the back. And this is the boost converter circuit, and these LEDs you see here is actually the output. They are all connected in series, so there are 13 of them. The turn-on voltage is about 1.8 volts, so that when you run it at 24 volts, it should all light up. And over here we have the potentiometer that we will tune to achieve the 24 volts we want. And this is the 555 timer, and this is the error amplifier, which is the op-amp. So we have the power supply here, which is set at 12 volts. So now we are going to connect it to the input. As you can see, it's drawing about 0.113 amps, and the LED is lit up. And we have these two wires here, which are taps for the output, so we can measure that as well. Yep, you can see the output is 24 volts DC. Okay, so here we have wired the oscilloscope to the output to see the waveform. And as you can see here, there is a frequency. This is because it's a switch mode power supply. And you can see the average is quite a good 23.95 volts. And the peak to peak is 3.5 volts. You can see here, there is a ripple at every periodic interval. Besides the strip board version, we actually did the PCB version of the boost converter. You can see that it's orders of magnitude smaller than the strip board version. And this design is really compact, and you can see that it's also working perfectly. You can see that the 13 LEDs in series are lit up, and the output voltage here is very close to 24 volts. This can be tuned, of course, with the potentiometer over here.